Okay, first thing, of course, make sure you write down the problem. Don't skip that step. That causes trouble. So y equals square root. Don't say it out loud. Please raise your hand. I'll pay the whole room. Raise your hand if you can tell me what rule I'm going to use first. It's not meant to be hard. I just want to make sure you're thinking with me. So on that pink sheet, what rule am I using first? Just give it another second here for a few more hands. Let's go, Lexi. So use the square root when you knew it. 4 points, 5 for Lexi. Go here. Square root. And I memorized the square root rule the same way I just mentioned. I say the derivative of the square root of something is going to be 1 over 2 times the root of that something multiplied by derivative of the something. So my next line I'm going to say dy dx equals 1 over, points again, hands up, what's the something in this case? I know these are easy, I'm just trying to make sure you're thinking with me and not just watching or getting sleepy. Nelson? How many knew it? Yeah, show me. 4 points, 5 for Nelson. So this rule says I get 1 over 2 times square root of the something multiplied by the d dx, or derivative of, that same something. This is a good day to be in class, lots of extra credit. I didn't write that correctly, hold on. If you are studying the video from home and you are actually studying the video, you're not kind of casually watching it as you do something else, and you're keeping up and you're taking notes, feel free to take the extra credit points. Like when I say, everybody tell me, and then you answer a question. It sounds really funny. I feel like I'm, anyway. For all of those that are at home watching this in the future, you can take the points as well. Okay? So hands up. What rule am I going to use here? What rule comes next, Tanner?
The addition or subtraction.
Hands up if you knew it. 4 points, 5 for Tanner. So I'm going to use the add subtract rule here. The add subtract one is another one I can do completely in my head, because all it says is, instead of thinking of the ddx of the two things together, the two terms together, you simply think of the ddx of each one separately. So my next line I'm going to write y over dx. This part I just copied. Okay, next thing, make sure you put a large parenthesis here. When using the addition property, that parenthesis will save you from a lot of test mistakes. So question, Berlin, I didn't mean to. Are you okay? You were asking them a question.
I figured it out.
You're good, no worries. And you're totally fine to ask them. I was just trying to help if I can, so you're good. Always put the parenthesis when using the addition rule. This one here. Okay, now I've got d dx of e to the something. I'm just doing that in my head. d dx of e to the something. Just say it out loud. What's the something? Say it. Negative 2x. E to the something. Negative 2x. The e rule is another easy one. The derivative of e to the something is e to the something multiplied by d dx of that something. Okay? The derivative of 2 is going to be 0. Now, don't be hesitant. Go like this if you need to see more detail off to the side. You don't have to show everybody. I just need an indication I need to show something. Okay, cool. Next line. Hey, we're done. Because I know this. that's just the multiplying constant rule. I pull out the -2, I have -2 times dx dx. That's just -2. So what I have now is a bunch of factors. On the bottom, I have a factor of 2. I have a factor of this root. On the top, I have a factor of e to the -2x, and I have a factor of -2. I can combine the factors any way I choose. So my choice is to take the -2 in the numerator, the -2 that comes from here, multiply that -2 by the 2 in the denominator to give me -1. So I'm going to get dy dx. It's -1. I still have this factor in the numerator. And in the denominator, I still have the root factor. Five years of engineering school at BYU, we were told to box every final answer. I've developed a habit. So, question? You don't need to see more detail. Just tell me. I'm glad to show as much detail as helpful. Jacob?
So I see you put the -1 8. Do you have to put that -1 because it's not in the answer?
Gotcha. 4 points for Jake. Here's why I do it. This is kind of a sarcastic statement. I'm not good at sarcasm, so I always warn you that I'm going to be trying to be sarcastic. It kind of defeats the whole purpose, but whatever. Okay. And I may have said this before. I'm having a really hard time. Like, it used to be a little hard to keep track of, okay, you know, A day, B day, have I told the same story in which class? Now there's like, instead of 6 class, I got 12. And I can't remember who's in which period and whether I've told you the story or not. But anyway, sarcasm not my strong point. But here's the point. I've learned this, Jacob. It's really interesting. I can create a problem, and if that problem contains this expression, about 2/3 of the class will make a mistake and pick the wrong answer. Like, there'll be more to it than that, but if it contains that expression, 2/3 of the class will pick the wrong answer. The negatives cause all kinds of trouble. But if I do this, notice the subtle difference. Like, I just put in some constants, -2, -3. No one makes a mistake. I find it fascinating. So the difference is, when there's not the 1 written down, people forget that there really is a 1. Like, this really is this. And so if I remember to put in the 1, I don't make a mistake. So I highly recommend that you write in the 1. You don't have to, it's not required, but I promise it'll prevent errors. Just remembering that, oh yeah, there's really a multiplying constant right there. It's not -x. It's -1 times x. Just like this is -3 times x. Does that make sense?
Yeah.
Okay, 4 points for Jim, please.
So is it okay to leave a negative exponent on the top of the graph?
Yes.
That's fine.
Yeah, that's a myth. Sorry, I know there's lots of teachers that say, you can never leave.
I think you say like you can't, like you've always got to make sure that it ends up on the bottom.
So there's this huge difference between what's truly a rule and what's a tradition. Okay? So leaving negative exponents, that's a tradition. In my work as an electrical engineer, there's a lot of circuit analysis that I did where we absolutely wanted to leave that exponent negative. Because it did a better job of illustrating what was happening. It was easier to work with. So you'll see me going back and forth all the time because there's no requirement. Yeah, absolutely not. 4 points. And even better, David, on the written half of the AP test, you can leave things really messy and still get full credit. So I will constantly teach you on the written section. Oh, good enough, stop, let's go on. People go, wait a minute, don't we have to like simplify? I'm like, no, done. You know, on the multiple choice, I've got to make it look like the multiple choice answer, but but they'll have negative exponents. They'll have roots on the bottom, which I know is another taboo. Like, oh, don't ever have a root on the bottom. Right? David's going,
Yeah, I was like,
Yeah.
do I need to finish that at all? But then,
4 more for David. You do not. So, just that's one thing I really like about this class as well. Is to me it makes more sense. There's not this foolish tradition. Foolish tradition of doing things that aren't really necessary. But anyway, I'm kind of biased because. Sorry, the engineering department and the math department have a bit of a feud at BYU, and I'm on the engineering side, so anyway. Okay, moving on. Questions? I put that all on video, that's great. Now, get